Hello, you're welcome to this class. Today we are going to continue with our discussion on polynomial. We talked about the concept of polynomial and arithmetics of polynomial in previous classes. Today we want to focus our attention on the zeros of polynomial. When we are talking about the zeros of polynomial, we are simply talking about the roots of polynomial. The roots of polynomial. Every polynomial has a power, and once a variable has a power, it can be factorized. That means that we can find roots for it. We look for roots of quadratic equation because a quadratic equation has a variable that has a power of 2. So because of the power of the variable, we can factorize it to get the roots. So any other variable, the one with power 3, the one with power 4, the one with power 5, and so on and so forth, we can factorize them to get their roots. Finding the roots of a polynomial is what we call getting their zeros. A zero of a polynomial is a value that you add to the polynomial function to get 0. For instance, if x raised to power 3, if you have a function like x raised to power 3 plus 2x minus 4, and we are told that a is a zero of this expression, what it simply means is that if we use a and replace x in this expression, if you put a inside this expression, we are going to get 0 at the end. When we add everything, we are going to get 0. So the roots of any function is a value that you add to replace the variable, and after doing the addition or subtraction or what have you, you are going to get 0. If 1 is the root of this expression, if you use 1 and replace the variable which is x in this expression, at the end you are going to get 0. If 2 is the root of this expression, if you use the 2 and replace the variable, at the end you are going to get 0. We can use this to verify the quadratic equations we have been solving. When you get the values for your quadratic equation and you are not sure whether the values you got are the roots or not, what you do is that you use the values, insert it inside the expression or inside the quadratic equation, and check if it will give you 0. If it gives you 0, it means that the value is the root, is the true root of the quadratic equation. If it doesn't give you 0, it means that it is not the true root of the quadratic equation. Now let's look at some examples. Assuming we have, let's start with a quadratic function. That is the one that the power is 2 as a polynomial. That is a binomial. Now if you have x raised to power 2 plus 2x plus 1, and we are asked to verify which one is the root of this equation between, if you are given x minus, if you are given x minus 1, x plus 1 and x minus 2, and we are asked to show which of these is the root of this function, or this quadratic function. What we are going to do is, first of all, the roots given to us, x minus 1, x plus 1, x minus 2. If you have x minus 1 and using the quadratic law, it means that x minus 1 is equal to 0 and x is equal to 1. For x plus 2, it means that x plus 1 is equal to 0 and x is equal to minus 1. For x minus 2, it means that this is equal to 0 and then x is equal to 3. So from this, what is equal to 2? So from this, what we have is, what we have as the value of x, we have that the roots given to us to verify are x equal to 1, minus 1, and 2. Now let's check which of these are the roots of the true root of the equation of this expression. Now we put each of these as the value of x. Use each of these value, put it as the value of x in the expression. Now that means that for this expression, x raised to power 2 plus 2x plus x raised to power 2 plus 2x plus 1. If we start with x equal to 1, now let's use 1 to replace the variable x. Now we are going to have 1 raised to power 2 plus 2 times 1 plus 1. Now we are going to have 1 raised to power 2 is 1. Now 2 times 1 is plus 2 is 2, and plus 1 plus 1. Now this is going to give us 1 plus 1 plus 2, 1 plus 2 plus 1, which is 4. So it does not give us 0. That means that this one is not a true root of this equation. It's not a root of this expression. Now let's check minus 1. Now for x equal to minus 1, let's say f, this is function of x, where x equal to minus 1 now is equal to, the equation given to us is plus 2x minus plus 1. Now for 1, it is, for 1, it becomes, is equal to, let's use 1, minus 1 squared plus 2 brackets minus 1 plus 1. I use this function x to replace y, or just to show that we are looking for the value of this root. That's why I placed it. This is actually a function, and that is why I use f. Now x in brackets here shows that we are looking for the 0 of x. So each of the roots that we're looking for is 0. Each of the variable that we're looking for is 0. We use it to replace the x here, so that we will be able to identify which one we are looking for, we are finding. That is why I use this expression. We can actually leave it and solve, but it makes sense for us to put it like this, so that we can see what we are solving, or the one we are working with. Now, this is 1 raised to power minus 1 raised to power 2 is minus 1 times minus 1, which is equal to 1. Okay, and now 2 times minus 1. So we are now going to have 1. 2 times minus 1 is minus 2. Minus 2 plus 1 plus 1. Now this is going to give us 2 minus 2, and this is equal to 0. Therefore, minus 1 is a true root of the quadratic function. Now let's check the last one, 2. We put 2 again inside the expression for f, where x equal to 2, and we are looking for the 0 of the expression. So let's use 2. It becomes 2 squared plus 2 times 2 plus 1. This is going to give us 2 squared is equal to 4 plus 2 times 2 is equal to 4 plus 1. This is equal to 8 plus 1, which is equal to 9. So this is not equal to 0, and that means that 2 is not a true function of the is not a true root of the function or a true root of the expression. The only root of the expression in the option given to us is minus 1. So that is how to do it. You put the values given to you as the roots inside the function, use it to replace the variable, and check if it will give you 0. The one that gives you 0 is the true roots of the function or expression. The ones that do not give 0, they are not true roots of the expression or function. Now let's look at another example. Now let's actually, before we look at another example, let's solve that quadratic equation and see whether the root is minus 1. This is the quadratic equation. Let's just do confirmation. X squared plus 2x plus 1. If you want to factorize this, this is going to give us x squared, two numbers that will give us, that if we times them, it will give us 1, and when we add them, it will give us 2. Let's say the only thing we can times to give us 1 is 1 and 1. 1 times 1. 1 times 1 is equal to 1. 1 plus 1 is equal to 2. Okay, positive, positive. So we use the 1x now to replace this. So that becomes x squared plus x plus 1, which gives us x squared plus x brackets plus x plus 1. Now this gives us, for this one, x bracket x, let me write it somewhere else. So that gives us, it gives us x bracket x plus 1, x divided by this, by x, it gives us 1, then plus, for this one, the common thing between x and 1 is 1. 1 can divide x and 1 can divide 1, so we have 1 bracket x plus 1. So we have x, we collect the ones outside the brackets, x plus 1, then we take one of the brackets, x plus 1. So it means that we have just one root for it, which is x plus 1, and that means that x is equal to x plus 1 is equal to 0, and that means that x is equal to minus 1. So the one we got as the root is actually the correct one. So that is why That is why minus 1 here showed up as a 2 root of the quadratic equation there. Now let's look at another example. In this example, we are asked to confirm if to check if x plus check which of the following following options are the roots of x squared plus 3x plus 2. Now the options given to us are we have x plus 3, we have x minus 1, we have x plus 1, and we have x plus 2. So these are the 4 options given to us. Now let's confirm which of them are the 2 roots of the equation or the expression given to us. Now let's start with the first one. X plus 3 means that x plus 3, if you equate this to 0, it means that x is equal to minus 3. Now let's put this as the function to check for the 0 of the expression. So function of x when x equal to minus 3 is equal to, expression is x squared plus 3x plus 2, that is minus 3 squared plus 3x plus 2. Now that is going to give us minus 3 squared plus 3 bracket minus 3 plus 2. Now this is going to give us 9 plus 9 minus 9, minus 3 times 3 minus 9 plus 2. This is going to give us 2, not 0. So this is not a 2 root of the equation. This is not a good option. So we look for another one. The second one is x minus 1. For x minus 1, it means that x is equal to 1. That is, from x minus 1 is equal to 0. If you take 1 to the other side, it becomes x equal to 1. Now let's find function of x when x equal to 1. Now this will give us 1 squared plus 3 times 1 plus 2. Now this is equal to 1 squared is equal to 1 plus 3 times 1 is 3 plus 2, and this will give us 2 plus 1 plus 3, 4 plus 2, 5. This is not equal to 0. Therefore, this is not a function, it's not a root of the function. So this one cancelled. Now you go to the third one. The third one says, the third one is x plus 1. X plus 1. So for x plus 1, we now know that x is equal to minus 1. And that means that function of minus 1 is equal to minus 1 squared plus 3 bracket minus 1 plus 2. Now this gives us 1 minus 1 times 3 will give us minus 3 plus 2, and this will give us, this is 3 minus 3, 3 minus 3, and this gives us 0. So this one is a true value or a true root of the expression. X plus 1 is a true root, that is x equal to minus 1 is a true root of the function. Now we look for the fourth one. The fourth one says x plus 2. So let's check for x plus 2. Now for x plus 2, we know that x is equal to minus 2. Now that becomes the function of x when x equal to minus 2 is now equal to minus 2 squared plus 3 bracket minus 2 plus 2. This is going to give us 2 raised to power 2 minus 2 raised to power 2 will give us 4. This gives us 4. 4 minus 2 times 3, that gives us minus 6 plus 2, and this gives us 6 minus 6, 6 minus 6, and this gives us 0. Therefore this one is also a true root of the function. So our roots for the function are x plus 1 and x plus 2. Now please note this. Instead of giving us this like this, they can give us the value of x directly. Here, what I mean is that here, they can just ask us, check which of the following options are the root of this expression. Now instead of saying x plus something, they will just give us where x, that x equal to, they can say x equal to maybe 3, 1, minus 1, and minus 2. They can give us something like this instead of giving us x plus something. If they give us x plus something, it means that we should determine the value of x by equating it to 0 and then put it into the function. But if they give us the value of x straight, that means they have solved it to get the value of x for us in the root. They have given us the exact root. So we now do the calculation by just putting the value of x that we got. So that is it. That is how to solve the zeros of polynomials.